It seems that no matter how much workshop space you have never have enough. Maximizing machine use is a big deal. In this video, we're going to convert a 14-inch woodworking bandsaw to a dual metal cutting machine with minimal changes and for minimal cost. There is a pointer later in the video to download the files for a 3D printed cover for the speed controller we are using. I have a good-sized woodworking shop and an ever-growing machinist shop, with lathe, mill and some CNC machinery in development, with lots of future wants. It all takes up floor space. Pretty quickly when building out a machinist shop, you realise that a power saw is essential. A hacksaw is just not going to cut it. I would love to have one of these for woodworking, one of these for cutting stock to size, and of course one of these to deal with sheet and plate metal cutting. Instead, I have one of these, a 14-inch import bandsaw that has worked fine for many years in the woodworking shop. The goal is to leverage the existing bandsaw for as many bandsaw-y purposes as possible. The first problem is to significantly reduce the speed of the bandsaw. A woodworking bandsaw operates at between 1500 and 3500 surface feet per minute. Metal cutting bandsaws operate at between 160 and 300 surface feet per minute. We could step this down using extra pulleys, but that requires a lot of modification, and then we would just have a metal cutting bandsaw. Instead, we're going to use one of these, a speed controller for a DC motor, and also change out the existing motor for one of these. I am losing a little power going from 1 horsepower to 3/4 of a horsepower motor, but DC motors develop full torque at low speeds and across the full operating range. This is a fair trade-off to allow the bandsaw to be used for woodworking as well. This DC motor is currently available on eBay, cheaper than what I paid for it. The speed controller comes with spade connectors and a variable resistor. So other than the DC motor, there is not a lot required. The controller is about 4.5 by 3.5 inches. The exact dimensions are provided in the manual, which is helpful if you want to design an enclosure. The DC motor is plug compatible with the original motor, which was one of the reasons for picking this style. You will need to pick a fuse based on the size of the motor you choose. In my case, I am using a 15 amp fuse. I am running 110 volt supply, so the fuse is inserted in line with the L1 connection. The jumpers need to be set for 110 volts line voltage and 90 volts DC output. The optimal torque is set using the trim pots on the board. The old motor is removed from the mounting plate. Then the pulleys on the drive shaft have to be pulled. Not having a pulley puller, I had to resort to the careful application of a couple of levers. The speed controller is still available on eBay, although a little more expensive. You may be able to find it cheaper elsewhere. I made a 3D printable cover for the speed controller, which you can find at the Thingiverse link below. The wiring is pretty simple. We need a 15 amp fuse in line with the supply side and the wiring for the variable potentiometer. The wiring gauge used here is overkill, but it was all I had on hand. All of the connections to the speed controller board use the supplied spade connectors crimped to the wiring. The base plate for the speed controller is a heatsink for the printed circuit board. For installation, the base is coated with heat grease, so the connection with the base cabinet of the bandsaw provides a larger heatsink. This is admittedly overkill, but it costs only a little extra effort. The potentiometer can be seen just to the left of the board. The board is installed in the bandsaw base cabinet, and a wiring block keeps the wiring organised. The potentiometer was installed next to the power switch to provide speed control. Then the DC motor is wired in. Before getting crazy with the motor installation, we give it a smoke test. Sure enough, the potentiometer varies the speed of the motor. So, on with the installation of the pulleys onto the DC motor spindle. The motor is installed on the mounting plate and the belt is tensioned. Wipers are made from a nylon paintbrush to keep the tyres on the wheel clean, and are attached to the wheel covers so they rest against the tyre of the bandsaw wheel. A vacuum port is installed to collect any additional swarf. If you are using a central dust collector, use a cyclone pre-stage or something similar to ensure that swarf does not hit the blades of the fan. The resulting sparks can be explosive with wood dust. Alternatively, use a shop vac as seen here. With a new metal cutting blade installed, the modified saw sliced through this 1-inch diameter cold rolled steel bar with ease. The final step is to update the bandsaw description. The current configuration works well with ferrous and non-ferrous materials and still has enough top-end speed to support my woodworking requirements, using different blades of course. I could maybe wish for a little more torque, but the trade-offs are perfectly acceptable until I can get an extra 500 square feet of workshop space. Please click the like button and subscribe to see the next eclectic build.